Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to electromagnetic theory. So far in the previous videos we discussed some questions on displacement current. So in the next series of videos we'll be discussing some questions on properties of electromagnetic waves. This is the first question. So it is given that in an electromagnetic wave the electric field intensity that is equal to 100 volt per meter. We have to find the value of magnetic field intensity or the magnetic flux density, B, the magnetization force or magnetic intensity, H, and the energy density. Okay, these three things we have to calculate. So for that, what we'll do first, the basic representation of the electric and magnetic field vectors. So first, the electric field is represented by E0 cos omega t. Simple representation. It is E0 cos omega t minus kx minus omega t. That is not required here. Simple representation will keep it according to the data which is given here. So according to the data, this peak amplitude that is equal to 100 volt per meter. Okay. So from this we can calculate B, the magnetic flux density, with the help of the relationship, which is that for an electromagnetic wave, the ratio of the peak or the amplitude of the electric wave and the amplitude of the magnetic wave, that is equal to C, which is equal to 3 into 10 to the power 8 per second. So that implies B0 that is equal to E0 by C, which is equal to 100 by 3 into 10 to the power 8. That is equal to how much? It is coming around 3.33 into 10 to the power minus 7 Tesla. Okay, that is the magnetic field intensity or the magnetic flux density. Then this is the first bit. Then we have to calculate, okay, this is the first bit. Then we have to calculate the magnetizing force or magnetic intensity, H. So here we'll be using the relationship. If you know some basic concepts of magnetism, so here the relationship is magnetic flux density B is equal to mu 0, which is absolute permeability or permeability of free space, multiplied with the magnetizing force or magnetic intensity H. So that implies H is equal to B, in this case it is B0 by mu 0. So that is equal to how much? 3.33 into 10 to the power minus 7 by mu 0 absolute permeability, that is 4 pi into 10 to the power minus 7. So it is coming around 0.265 ampere per meter. So this is the magnetizing force or magnetic intensity. Then it is asked to find the energy density or the average energy density. So here we have to find the total energy density. So if you remember, in the properties of electromagnetic waves, we discussed that the total energy density of an electromagnetic wave is the energy density of the electric field and the energy density of the magnetic field, because it is equally shared between the two oscillating or vibrating fields. So UE is equal to 1 by 2 epsilon 0 E square, and UB, because of the magnetic field, that is equal to 1 by 2 B square by mu 0. Okay, and as it is equally shared, so UE is equal to UB. So this we can write it as either 2 UE or plus 2 UE or 2 UP. In any way you write it, it will be correct. So here the total energy density UT is equal to 2 UE, which is equal to epsilon 0 E square, or 2 UB, which is equal to B square by mu 0. Either ways, in this case it is 8.85 into 10 to the power minus 12 into, it is given the electric field, that is 100 volt per meter square. So it is 8.85 into 10 to the power 100 square is 4, so 10 to the power minus 8. That's that much joule per meter cube. And here also it will be the same. B, which we calculated, the value of B is 3.3 into 10 to the power minus 7 whole square by 4 pi into 10 to the power minus 7. That will also be equal to same 8.8 to 10 to the power minus 8 joule per meter. So either way you go, you will get the same result. Okay, so here we have determined all the parameters which were asked. Okay, yes.